Hi, welcome to Khan series. In this video, we will talk about the top 25 PySpark interview question and answers. Question: difference between RDD, data frame, data set in PySpark. RDD has API level low, where data framework and dataset have high API level. RDD is and dataset are type safe, but data frame is not. RDD is a unstructured data. You may not have a schema, but data frame and dataset have schema because mostly they are structured data. In data frame and dataset, we have crystal optimization technique. In RDD, we have Java serialization. In data frame, we have binary format. In dataset, we have encoders for serialization. Performance wise, RDD is slow as it is a unstructured data, but data frame and data sets are high performance. As I said that RDD is a structured data. RDD is a unstructured data, and data frame and data set are structured data. Question: explain Spark lazy evaluation. Spark lazy evaluation is the core concept of where transformations of really RDDs or data frameworks are not executed immediately when defined. Instead, Spark builds a logical execution plan and represented as a DAG directed acyclic graphic and defers the actual computation until an action is triggered. The transformations are lazy in Spark lazy evaluation. When you apply transformations like map, filter, group by join to an RDD or data frame, Spark does not immediately process the data. Instead, it records the operations in the DAG and essentially create a blueprint for computations to perform, and then it will execute the action when the event is triggered. Next question: what is the role of Spark section? A Spark section is an entry point for the interaction with PySpark functionalities, acting as a unified API that combines Spark context, SQL context, and Hive context. Since Spark 2.0, its role is to provide a single unified interface for creating data frames and datasets, reading and writing data in various formats, executing SQL Server queries, and accessing other Spark features. The roles of the Spark section are unified entry point, data frame and dataset API, and data operations, SQL query executions, configurations, and access to the Spark functionality. How do we write a How do we read a CSV Parquet JSON file in PySpark? Here you can see various SQL, Spark PySpark code that has been used to read those files. This is how you read the data from the various files, and you can add them into the data framework and use them in your process, PySpark process. Difference between CSV, CSV or JSON file and in PySpark. Here we will see the differences of various types of file format. We don't have columns in CSV or JSON, only in sorry all of these file formats are splittable and compressible. CSV and JSON are readable by humans. JSON and Prankvet have nestable, not CSV. There are complex data structures in JSON format and Prankvet, but not in CSV. Default schema named format are available in JSON and Prankvet, but the schema is done manually in CSV. Next question: what are transformations and actions in PySpark? Transformations: the output of the transformations is new data set. For actions, it is value. For example, write data. The execution of transformation is lazy and it is only planned. For actions, it will be triggered by an action and immediately computation for immediate computation. The optimization of the transformation is happens when Spark optimizes the overall execution plan. Similarly, for the action as well. For defining data manipulation pipelines, we use transformations. For retrieving the results and interacting with the external systems, we will use actions. What is a wide transformation and narrow transformation? In narrow transformation, every partition is used by one child partition. Each input partition can compute one or more output partitions, but the mapping is contained within the partition. For wide transformation requires data from multiple partitions. Data from multiple input partitions is needed to compute a single output partition. In narrow partition, there is no shuffling required, but in wide partitions involves shuffling of data. In narrow transformations, Action lead to less data shuffling across the partitions. In wide transformations, the actions lead to huge data shuffling across the partitions is called as wide transformation. Performance wise, narrow partition is more effective because there is no shuffling of data. In wide transformations, the data is less effective performance. For example, for narrow partitions, we have map, filter, union, and map values. For wide, we have group by, reduced by, join, distant, and repartition. The narrow partitions are simpler and fast, where wide transformations are complex and slow due to the data movement. How do you handle missed and null values in pyspark data framework? For this, we will have to use functions like drop NA, fill NA. Using these, we will be upgrading, so we will be removing the null values or missing values. You can see the code syntax in this. Next question: how do you persist cache data in PySpark? Cache stores the data in memory only, but persist will save data in memory and disk as well. Cache is a simplified and default storage level where persist offers various options for storage levels. For simple caching scenarios, we can use cache method. For complex caching scenarios where we require different storage levels, we use persist. Easier to use where cache is easier to use shorthand for memory only. Where persist is more flexible, allows custom storage options. Cache is suitable when memory suffix, where persist is more efficient when dealing with larger datasets and limited memory. Next question: what is the difference between repartition and correlations? In repartition, we can increase or decrease the number of partitions. In coalescence, we can only decrease the number of partitions. Repartitions involve full shuffle. Coalescence avoids full shuffle and more efficient. Repartition is more expensive due to shuffling. In coalescence is more efficient for reducing partitions. Using increasing repartition is used for increasing partitions or decreasing the load. But in coalescence is used for reducing partitions typically after filtering. Repartition is costly for large data sets. Coalescence is more cost efficient for reducing partitions. In repartitions, data is evenly distributed across the partition, where in coalescence, data is unevenly distributed across the partitions. How do crystal optimization works in PySpark? Crystal optimization is the core optimization framework within the Spark SQL, responsible for transforming large level queries, SQL data frame dataset API into efficient execution plan. It operates through a multi-phase process. The initial query, whether SQL or data frame operations, is phased into a unsolved logical plan. Crystal Optimizer has resolved reference like column table functions against the Spark catalog, creating a resolved logic plan. This phase ensures all elements of the query are valid and correctly typed. The logical operation is planned and physical planning is done and the code is generated. Thus, the crystal optimization works in Spark. Difference between map, flat map, and map partition. The map returns one output element per input. Flat map can return zero or more output elements per input. Map partition, one partition iterator of output elements. Map does not flatten the output. Flat map will flatten the output into a single level. Map partition does not flatten the output. Map is suitable for one-to-one transformations, where flat map is suitable for one-to-many transformations, and map partition is used when you want to optimize the performance by reducing the function call overhead. Map is simpler, but flat map is complex due to variable number of outputs, and map partition is also complex. How do you broadcast variable in PySpark and why? Broadcast variable involves in making a read-only copy of variable available to the all nodes in a cluster. When a partition uses for small unlookup style data that needs to do accessed by many tasks across different executors. It is used for optimization of performance and it also reduces the memory consumptions and efficiency in joining the data. Wha- What is the checkpointing in Spark? Checkpointing in Spark is a mechanism to persist the state of resilient distribution or framework to a reliable distributed storage system such as HDFS or Azure S3. This process offers significant benefits for performance optimization and fault tolerance in Spark application, especially in iterative algorithms and long running streaming jobs. The key aspects of checkpointing is breaking lineage and performance optimizations and fault tolerance reliability and check directory eager was and it is used in stretched streaming. Explain the Spark execution flow. In Spark, the driver receives the user code and on an action call it converts it into a DAG directed eccentric graph of RDD and data frames. The DAG scheduler then splits the DAG into stages based on the shuffled boundaries. The task scheduler breaks these stages into small units of work called tasks. These tasks are sent to the executors running on worker nodes for parallel executions, and results are sent back to the driver. And the cluster manager allocates the resources and instructs the workers to execute the job and tracks submitted jobs and reports back to the status of the job. How do we handle data, sweet data in Spark joins? Sweet data means the bottleneck of the data while performing the operations in Spark. There are various strategies are employed to perform to handle this issue. Salting. Add a random salt value to the joint key of a larger sweet data. This distributes the sweet keys across more partitions. Replicated the small data frame by creating multiple copies, each with different salt values matching the range used in the larger data frame. Perform the join on the new salted key. Remove the salt column after the join if no longer needed. Broadcast hash join. If one of the data frame is small enough to fit into a memory of all executors, broadcast it. This avoids shuffling the large data framework and eliminating the true issue related to the join key. Adaptive query execution and repartition. Isolation screw data. These are those various other steps that can be used to handle the screw data. Difference between Spark streaming, Kafka streams, and stretched streaming. In Spark streaming and stretched streams, we have micro batches for execution, but in Kafka streaming, we have continuous streaming. For fault tolerance, we can use checkpoints in Spark streaming and structured streaming. But in Kafka streams, transactional messages and important producers are used for fault tolerance. Latency is high in Spark streaming and structured streaming, but it is low in Kafka streaming. SQL features are available in structured streaming and KSQL for aggregation purpose in Kafka streaming. Windows support is available for Spark streaming and structured streaming. For Kafka streaming, Windows support like sliding window, hopping window, section window, and trembling windows are available. Dstream with RDD is done in Spark streaming, but the structured streaming is built on Spark SQL on data framework and data sets. Kafka streaming uses RDD and data frame. Spark streaming cannot handle late data as it depends on timestamp. Structured streaming can handle late data and process data on the basis of event time. Kafka streams have continuous streaming. Water marketing is not done in Spark streaming, but it can be done in Kafka streaming and structured streaming. How do Spark handles shuffling and why is it expensive? Spark shuffling data like when operations like group by or joins requires data with the same key to be joined together across different partitions or node. This is an expensive operation because it involves extensive network and data input output to move large data sets between the Spark executors, consuming significant CPU and memory resources and increases execution time. It can be handled by using shuffle writers, load file system, shuffle managers, and shuffle reader and network input output, disk input output, CPU consumption, execution time, data slippage, minimize shuffling, use appropriate partition. Explain the difference between tungsten execution engine and crystallite optimizer. Crystal optimizer is query optimization, where transient execution engineer is a runtime execution optimization technique. Crystal catalyst optimizer runs before the execution, but tungsten execution engine runs during the execution. Cas- Catalyst optimizer is logical and physical plan where tungsten execution engine is memory and CPU efficiency. Catalyst optimization is rule based and cost based, where transient execution is off hype memory and code generation. Catalyst optimization reduce computation. Transient execution engine reduces CPU cycles and memory usage. How do you optimize Spark jobs? It can be done by various things like partition tuning, the number of partitions that can be done, data strew, and we can use caching and persisting the data, and we can avoid shuffles by minimizing the byte transformation, data localization, and broadcast joins, and filter early and optimize data formats, tune Spark configurations, and avoid UDF when possible. What is the difference between narrow dependency and wide dependency? Narrow dependency has one-to-one mapping, where wide dependency has one-to-many mappings. There is no shuffling in narrow dependency, but shuffling is required in wide dependency. As because of the shuffling, wide dependency is slower compared to the narrow shuffling. For narrow shuffling, the examples are map, filter, flat map functions. For wide dependencies, the examples are group by key, reduce by key, join, and distant. How do you handle out of memory issues in Spark jobs? To handle out of memory issues in Spark jobs, we we mostly use configuration tuning like increase driver and executor memory, adjust executor cores, increase shuffling partitions, and use garbage collection tuning. And we can also do code optimization by minimizing the collection usage and have a efficient cache, reduce shuffling, and handling the data screw and efficient data structures. Monitoring and debugging using Spark UI, executor logs, and cluster monitoring tools. Thus, we can handle the out of memory issues in a Spark job. Explain Windows function in Spark SQL with an example. Windows function in Spark SQL perform calculations across the set of rows related to the current row known as window. Unlike aggregate functions that collapse multiple rows into a single result, Windows functions return a value for each row, allowing for calculating like moving averages, rankings, comparisons, and presuming succeeding rows while preserving the original row count. Some of the functions are partition by, order by, row between, range between. Windows functions use sum, average, count, max, minis, rank functions, dense rank, row number, entail, lag, lead, queue descent, and prince, percentage rank, so on. What is preceded push down and how does it improve performance? Preceded push down is a query optimization technique where filtering conditions are applied as early as possible directly at the data source rather than the data has been transferred to the query engine. This strategy improves the performance by reducing the amount of the data that needs to be optimized and moved across storage levels, leading to master query execution types, better source utilization, and more efficient query optimization in data data systems like Apache Spark, Hive, and Data Lakehouse. Client-side decomposition, pushing to the source, server-side filtering, reducing data transfer are some of the ways that perform these operations.